Welcome to another episode of Branham's Safety Demos. Today we are going to be talking about TIG welding, and we are going to start out by identifying some of the parts of the TIG welder. So this is a TIG torch. This is what it looks like when it's all disassembled. So this is just the torch body. Here we have a collet body, and what that does is screws into the front of the torch right here. This doesn't need to be super tight. Don't put a wrench or anything on it. Just get it finger tight. The next part we have right here is what's called a collet. And be aware, there is a wide end and kind of a skinny end on it. The wide end is going to go towards the back. So we're just going to take that and drop it in the back side here. Just like that. The next part we're going to look at is what's called the cup. And on these cups, there's going to be a number. And what that tells you, this is a number 7 cup. So it tells me the ID of this from one side to the other is 7/16. So this number is in 1/16 of an inch. So if that was an 8/16 or an 8, that'd be 8/16. A 10 would be 10/16, and so on. And all that's going to do is that will screw onto your collet body. Just like that. That doesn't need to be super tight either. Just hand snug on there. And the last part is what's called the back cap. So the back cap's going to screw on the back of the torch right here. And on here there is an O-ring, and you need to inspect that O-ring and make sure it's good, doesn't have any tears or anything in it, because that's what is going to keep the gas from leaking. So what I'm going to do is I'm going to snug up my back cap. I don't want it to be fully tightened, so I'm going to take it to tight and then back it off about a quarter or half of a turn or so. And then I can take a tungsten and slide a tungsten into my TIG torch here. And I like to keep this gap about 3/8 of an inch or so. So once I get my gap set, then you can go ahead and tighten your back cap. And this doesn't need to be super tight, just gently tighten that, and that will keep your tungsten secure in there. So I like to keep my tungsten gap about like that, 3/8 of an inch or so. One other thing to keep in mind as you're assembling this, one of the common issues that I see is people don't get this collet body tight. And when you go to put your tungsten in here, so you get your tungsten adjusted to where you want it, you tighten up your back cap. Tighten up the back cap here. And then they notice that their tungsten can still move in and out. Just come back in and tighten up your collet body. Make sure you tighten your collet body first before you tighten your back cap, because that's going to put a bunch of pressure on there. So like right now, if I tighten the collet body and then I back the back cap off, the collet body is going to be loose now. So I'm going to go ahead and back my collet body, or my back cap, sorry, and take it all the way off. Tighten that collet body until it's nice and snug. Put my cup back on. And be really careful with all these parts not to cross thread them. If they feel like they're cross threading, back them off and try putting it on again. Go ahead and put the back cap on. So that's what your assembled TIG welding torch will look like. What you noticed as I assembled this together, I also put a tungsten inside of it. And there's two different flavors of this. There's red, and then there's also green. So that's going to correlate to what it is that we're welding with. So are we welding aluminum? Are we welding stainless? Are we welding steel? Stuff along those lines. So red will be used for stainless and also mild steel, and green will be used for aluminum. Okay, and that's going to correlate with the machine setting that we choose to use. That'll show you a little bit further in the video. Along with these, you got to be careful with your grind angle. So on aluminum, you see how it's kind of balled up on the end there. It'll do that after you use it for a little bit, due to the cleaning action when you use AC. But typically I grind these aluminum tungstens to about a 10-degree angle on the end. And then also with our steel tungsten, you can see how that's ground to about a 30-degree angle. That's what works well for steel. So 30 degrees for steel, 10 degrees for aluminum. And as you're grinding those, if you imagine my finger as the grinding wheel, you want to grind these. This is one of the rare things that you're going to grind facing up into the wheel, and just kind of spin it. What you'll find if you grind it facing down is the tip on here will kind of build up grind particles, and it won't weld very well. So make sure to aim that up. So now we're looking at the front of our Lincoln Square Wave here. And there's three settings: DC negative, DC positive, and AC. We're going to use DC negative anytime we're using a red tungsten, so that's on our stainless and mild steel. And then we're going to switch it over to AC if we're ever doing any aluminum. And you're never going to use DC positive. That'll just cause your tungsten to ball up, and it won't work well for you. This machine can also be used as a stick welder, so make sure this switch over here is up in TIG, which it should be. And then the last thing you have on here is an amperage dial. And a good rule of thumb is for every thousandth of thickness, you're going to add 1 amp. So say if something's an eighth of an inch, that's 0.125. So 125 amps would be a good starting spot for that. Same with like a 16th of an inch is 0.064. So like 64 amps would be a roughly good starting spot for that. And on this machine, it's not super accurate. It goes from 30 to 75 to 110. So you just kind of have to guess roughly where that is. And then you can adjust it from there. As far as gas flow, this measures CFH, cubic feet per hour. And we want our gas flow to be set somewhere between 15 and 20 CFH will work good for TIG welding. We don't have a lot of air movement in here, so that will be okay. Looking a little bit further in at our welding table here, we have a ground clamp that's going to be hooked up. I usually just leave it hooked up to the side of the table here. And then we also have a foot pedal that we can use. So I use my right foot dominantly, and so I'm going to use this pedal with my right foot. If you're left foot dominant, you'll want to use your left foot on it. And the way this works, if I set my machine to, say, 100 amps, when this pedal is pushed all the way down, I'm going to get the full 100 amps. And then as I back off, I'm going to get less and less amperage until I'm all the way off. And that shuts the arc off on the TIG torch. Right here we have some filler rod for you guys. On the right side here, we have some copper looking filler rods. Those are your steel filler rod. And then on the left side, there are some kind of silver looking rods, and those are aluminum filler rods. And the way I check to make sure it's not a stainless rod is if you take the end and bend the end over like that, that tells you that it's aluminum. That bent really super easy, wasn't hard to bend at all. If you were trying to bend a stainless rod, that'd kind of bend a little bit and then spring back, and it would take a lot more force to be able to bend it over like that. So as far as material prep goes, we have stainless, we have aluminum, and we also have mild steel we need to prep. So we'll start out with the aluminum. We look at it. It kind of has some weird discoloration to it, so we want to brush all that off, kind of clean it up a little bit. So to do that, we have a wire brush that is for aluminum only. We don't want to impregnate steel into this, because if we do, then as we start brushing, we're going to push all that steel into our aluminum and give us lots of issues with it. So I'm just going to brush this real quick. And the reason we want to brush this is we want to break up the oxide layer that's found on the top of this, because the aluminum oxide melts at about 3,800 degrees, whereas aluminum will melt at about 1,300 degrees. So you're going to have it way too hot by the time you get through the oxide layer to melt the aluminum. So typically, if you don't wire brush it, it'll get hot, 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 hot. And then as soon as you get through the oxide layer, it'll fall through the back side, just because the way that it works. So just brush it up real quick. It doesn't take very long. And you'll see now it's nice and clean, whereas before it looked about like that. After you get this cleaned up, the last step you need to do is grab some acetone and a blue rag. And there should be some acetone sitting right behind the Lincoln on the gray cabinet here. I like to keep only one of these out here. Remember, this is highly flammable, so you don't want to have this anywhere close to your welding booth. So usually I'll wipe my material down on the counter. That gives the acetone a little bit of time to evaporate. So just put a little bit on a rag here and give it a quick wipe down. Not much came off, but a little bit of aluminum oxide powder. So that's prep for your aluminum. And also sometimes what I'll do is take my acetone rag and wipe down any filler rod that I'm going to use, just to get any grinding dust or grime that's been floating around in the shop off of it. The next thing we need to look at is our mild steel. So mild steel, hot rolled steel, looks like this. It's got the black mill scale on it. So what you want to do to prep that is take it over to the belt sander, get it polished up so it's nice and shiny bright, and then I'll wipe that with a acetone rag also. As far as stainless goes, we have two things that look very similar in the shop. So they're both kind of gray, but you'll notice this one's a little bit more shiny, has kind of a gloss to it, whereas this one's a little bit more flat. So this is what's called pickled and oiled mild steel. So they took hot rolled steel, they pickled it, and they got rid of all the scale on it, whereas this is stainless right here. And another way you can check is by taking one of our welding magnets, and it'll stick to mild steel, whereas on a piece of stainless steel, it will not stick. And I also sometimes like to wipe my booth down, because if you run your hand across here, you see all that dirt that's in the booth. If you introduce that while you're TIG welding, you're going to run into a lot of issues. So just put a little bit of acetone on there, give it a quick wipe down, and that'll solve a lot of problems that you're running into. One thing that I've failed to mention is TIG welding safety gear. So when you're TIG welding, you can use regular stick welding gloves. I like to use TIG welding gloves. They're, as you can see, they're a lot thinner, a lot smaller. They give you a lot better dexterity as you're welding. You can feel a lot better what you're doing. So TIG welding gloves, they're nice. They're not required. You do need to have some sort of glove on as you're welding. One thing that people also get kind of lazy with is they start letting their arms be exposed. You got to keep in mind, as you're TIG welding, it's not like stick welding or MIG welding where you have some fumes that are blocking you from the arc. In TIG welding, you don't have any of those fumes, so you're going to get 100% of that radiation on your skin. So it doesn't have to be thick, but you do need something with a sleeve on it, and then the gauntlet on your glove will cover up the rest of where you might have a gap potentially right here. Also, I like to wear a helmet. I pulled the lens off this one. You can take a rag, clean the lens off on the front side, on the inside, clean the lens out also, so it's nice and clear. If you can't see what you're doing, you won't be able to do anything. And also, as far as the helmets go, out in the shop I have, I believe 2, maybe 3 TIG welding helmets that say TIG only on them. Those are only for TIG welding, for the sake of keeping those clean. Because as you stick weld, as you MIG weld, you're going to get smoke on the face shield of your welding helmets. So for the TIG welding, we want to keep those nice and clean. So I flipped you guys around, so we're looking at the welding booth here. The first drill I want you guys to practice is keeping the distance from the tungsten to the plate to about 1/8 of an inch. So I want you to just hold your hand right here, get your gap set, and then I want you to rock onto the pedal all the way down to the ground, and then slowly back off. And I want you to do that about 10 times. Get yourself really comfortable with it. As you're doing this, if you touch your tungsten in the puddle, you need to go back to the grinder and sharpen it. Don't try and fight it. It's just going to lead to a bunch of issues. So do that until you're comfortable with it. Once you're comfortable, what we're going to do is we're going to go ahead and start it up and slowly start working your way down your plate. Try and keep your puddle the same width. And I'm also keeping my torch at not straight up and down, but I lean it back about 10, maybe 15, 20 degrees, something like that. And I like to hold my torch like this. I know some people that like to hold their torch like this. I find I'm not nearly as steady if I'm holding it from the top. So I'll hold it like that. Some people will hold it over the top like this, and that will work well for them also. Figure out what's comfortable for you and use that. So after you do a couple runs, a couple beads without adding filler rod, then we can go ahead and grab a filler rod. And the trick when you start adding filler rod is we're going to have our torch at our 10 to 20 degree lean back angle, and we're going to add filler rod in so that the angle between the filler rod and the TIG torch is about 90 degrees. You see how the angle between here is about 90? That's what we're looking for. And one other thing too is when people start adding filler, you got to think there's a gas cloud that's going to be around this of argon from our tank. And when we add filler, you're going to dip it in, dip, dip, dip. If you move your filler rod too far out, you're going to move it out of that gas cloud. So it's going to oxidize, then you're going to dip it back in. It's going to oxidize, dip, oxidize, and you don't want that. So keep your filler rod nice and close in there as you're dipping, and you're going to dip right in the front of the puddle. Front, 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 and you're only going to push with this. So about like this angle right here, dip, move. Just like that. Same thing applies. If you accidentally touch your filler rod to the tungsten, just go into the back of the shop. There's a grinder back there that's labeled tungsten only, and just go ahead and regrind your tungsten. You can fight it, but you're going to end up with welds that drastically go downhill after you dunk your tungsten. Now we're over here looking at the big TIG welder, and this will do the same thing that the other one does. It just has a lot more options on it for you to set, which is okay. We can run it similar to that one, but we don't necessarily have to. So on here, on the front here, we have the DC negative setting, we have the aluminum setting, and then the DC or the DC positive setting. And to get between those, you can just toggle the switch. I'm just going to leave it on DC negative. Then as we flip this on, it's going to pop up with our amperage setting on the top here. You can adjust that with this dial right here. And I'm just going to start from the left and work my way right. So here we have our balance setting. For steel, a good setting is, I'll usually just turn that all the way up to 10. So it's on minimum cleaning because we've already cleaned the steel. However, for aluminum, I'll usually turn that up to about 7. And on here it says AC TIG, so just set it somewhere in that range. All these buttons you can leave the same. And then the other one I like to check is right here too. It's called post flow. So that's when you let off the pedal, how long is the gas going to flow for. And I usually have that set to about 7 seconds or so. On the right side here, we have a pulse setting. And the way this works is we have a background amperage, a pulses per second, and a peak time. These all three work together, and they work off your current set amperage. So when that light is green, that tells you the pulse is on. If you don't want it on, just poke the button again and it turns it off. So I'm going to turn it on. So the background amperage is a percentage of the amperage you are using. So to simplify my math, if I have this amperage set to 100 and I set my background amperage to 50, so it's straight up and down here, when it pulses to my background amperage, it's going to go to 50% of this, so it'll go to 50 amps. PPS is pulses per second, and I usually run that pretty low, like 1, maybe 2 pulses a second. Seems to work pretty well. And then the peak time is the amount of time in percentage that it'll spend at that peak versus the bottom. So I usually keep my peak time at 50% also. So background amperage and peak time usually are 50%, and then pulses per second somewhere around 1 or 2 pulses. As you look at all these TIG welding booths, they're all clean. There isn't any debris laying around on them. You have to keep that in mind when you're TIG welding. Everything has to be clean, 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 clean. The cleaner your weld station is, the better, the less issues you're going to run into. So as you are TIG welding, take your time, clean the booth up, sweep around on the floor, keep everything in here as clean as you can.